Guys. So this week we're going to continue our discussions on statistics. Last week at the very end, we started talking about measures of center. So that included the mean and the median. We talked about skewed data versus normal data. And this week we're going to start by talking about measures of spread. So here's an example of a dot plot. A meteorologist recorded the average weekly temperatures over a 13-week period and displayed the data below. So you can see that the data looks pretty normal here. So 67 clustered around 80 being the most. A meteorologist in a different state also recorded the average weekly temperatures over a 13-week period and displayed the data below. So you can see if we compared the two dot plots, the one before, all the data was between 60 and 100. And in the other city, the data spread out a little further between 50 and 110. Measures of spread can tell us like how far the data is spread out or how close it's concentrated together. So the differences between the spread of data for these two data sets is pretty simple. All you really want to say there is that the second set is more spread out. All right, so let's look at specifics about spread. So there's actually two different ways that we can talk about spread. Just like we had mean and median for center, for spread, we're going to talk about the first way, which remember when we talked about box plots is the IQR, the interquartile range. We're going to use the IQR when we have skewed data. And why that's important is because the IQR is not affected by outliers. And those outliers are what makes the data skewed. So if we look at this data set, 5, 5, 6, 7, 8, 8, 8, 9, 10, 12, and 12. What are the first and third quartiles? Okay, so we want to make sure that we break this up by the median first. So there's our minimum, our maximum. Median would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 data points. 1, 2, 3, 4, 5. So this 8 would be our median. So that means 6 would be the lowest quartile, our first quartile, and 10 would be the third quartile or the upper quartile. So our first quartile would be 6, and our third quartile would be 10. And the IQR is just the third quartile minus the first quartile, which is 4. And again, I kind of talked about this already, but why would we use the IQR for skewed data? Now, this data is not skewed, but if it were skewed, it's because that middle 50%, that IQR, is not going to be affected if it's skewed. So, oops, sorry about that. So the IQR is unaffected with skewed data. All right, good. So let's look at the other way that we're going to talk about spread. So this is standard deviation. Standard deviation is a type of statistical analysis, and it's talking about how far values are from the mean. The larger the standard deviation, the farther all of the numbers are from the mean. And we usually want to use standard deviation for normal distribution. Because if you remember back to center, we used median when we had skewed data, and then we used mean when we had normal data, because with skewed data, the mean is going to be way more affected. Same with standard deviation. So if we look at these two dot plots, which of these has a larger standard deviation? Meaning, which of the data is more spread out? Which data has values that are farther from the middle? And that would definitely be B. And the reason why it's B is because they're more spread out. our data goes from 60 to 100 in B, and it only goes from 70 to 90 in dot plot A. Okay, so let's look at an example. So the Bozeman Bucks and Tate Aggies cross-country teams ran an obstacle course. The times for the teams are summarized below. So here's the list of the times, and then so the Bozeman have specific times, and the Aggies obstacle course are displayed in a box plot. So we don't know their specific times, but we know those 5 important values. So which statements are true about the data for the Bozeman Bucks and Tate Aggies? Select all that apply. So that means we're going to pick at least one correct answer. So the median time of the Bozeman Bucks is less than the median time of the Tate Aggies. So if we look at the median time of the Tate Aggies, I would say that's about 7:45, we'll say. So let's go ahead and find the median of the Bozeman Bucks. So it would be between 5.52 and 5.54. So I would definitely say that is true. The median is much less. The fastest 25% of athletes on both teams completed the obstacle course in about the same time. So for the Bozeman Bucks, it was between 6:48 and 8:05. And for the Tate Aggies, it was between 9 and 10. So they were within about a minute. So I would definitely say that that's true. Oh, sorry, fastest. I messed up there. So not slowest, fastest, because we want to go faster than everybody else. So between 4 and 5, and between 4 and 5 for the Bozeman Bucks. So that one is true. Sorry about that. And then the third one, the interquartile range of the Bozeman Bucks is less than the interquartile range of the Tate Aggies. So the Bozeman Bucks goes from 5:21 to 6:33. So that's about a minute and 14 seconds. Oh, sorry, 12 seconds. Here goes from 5 all the way to 9. So not even close. So Bozeman Bucks is way less than the Tate Aggies. Approximately 50% of the Tate Aggies have times between 5 and 6 minutes. So if we look at the Tate Aggies box plot, that is not 50%. That's less than 25%. Now, if they were the Bozeman Bucks, they were about between 5 and 6 minutes, but it's talking about the Tate Aggies. The data for the Bozeman Bucks is skewed to the left. I disagree. It looks like the Bozeman Bucks are pretty normal distribution if we were to plot it, so I'm not going to check that one. So just the first 3 of those were true. All right, so let's look at a different comparison. So the following box plots represent the starting salaries, thousands of dollars of 12 recent business graduates, 12 recent engineering graduates, and 12 recent psychology graduates. Describe the shape. So the shape is either going to be our skewed or our normal. So if we look at business, you'll see that the box is not in the middle. It is way more to the left, but remember, we want to think the opposite. So business is going to be skewed right. And what that means for the data is there's probably someone in the business graduates that make a lot more than all the rest of the people. So that's why it's skewing that box over. Engineering graduates. Now, if you look at the engineering graduates, you may want to say normal, but the problem is that median. That median is not in the middle of our box. So I would actually say that it's skewed. And because that median is shifted to the right, it's actually going to be skewed to the left. So there are values that are over to this left that are pulling that median. So it's making it skewed. And then psychology is not extremely perfect, but it's the closest to normal that we can get here. So that one's normal distribution. Part B, which major has the largest median salary? The largest median, and I'll write that over here. If we're looking at the line inside the box, that would be engineering. And then what has the largest IQR? And that would also be engineering, the largest box. And what that means, if we were talking about should you be an engineer, how much money will you make? That just means for engineering, there's a lot of different salaries you could be making. It's not going to be like a guaranteed amount. Now, if you're talking about business, that box is smaller, so you have a better chance of making the salary that's within that box. And engineering is a little bit more unpredictable, I guess is what we could say there. All right, let's look at the last question. So the data from a survey of the ages of people in a CrossFit class were skewed to the right. Part A, the appropriate measure of center. So if we're talking about skewed data, the center, remember we want to use the median because that mean is not going to be very accurate. And if we're talking about skewed data, we also want to talk about the interquartile range because that is not going to be affected by those outliers, that skewed data. So here's the box plot. Calculate the appropriate measure of spread. So we want to use IQR here. So that means we're using the interquartile range. So we'll have 18 as my lower quartile, quartile 1, 25. So 25 minus 18 would be 7. All right. If you guys have any questions, make sure you send me a message on Remind or email, and I look forward to hearing from you guys. Bye.